Hello everyone, welcome to another section of Schneider Electric PLC training tutorials where you will learn Schneider Electric PLC programming. So let's see what we have in this lesson. In this lesson we are going to study the flip-flop logic operations. We will start with the set reset flip-flop, the reset set flip-flop, and we will end it with some exercise. To begin, we will start with the SR flip-flop or the set reset flip-flop. This is a set dominant flip-flop, and this is a symbol of the function block. So you can clearly see it is a set reset flip-flop. It has different pins which have different functionalities. First, we'll talk about the enable pin. This pin is used to enable this block. So when this pin is enabled, then this block carry out its operation. Then we have the error notification pin. If this block executes with some error, this bit is set to 0, otherwise it is set to 1. So if it executes successfully, it is set to 1. So how does this block function? It functions as such. When S is set to 1, the output is 1. When R is set to 1, the output is 0. And when S and R are both 1 at the same time, then the set dominates. That's why it's called the set dominant. Then the set dominates and the output is set to 1. And if both of them are 0 at the same time, then the output is set to 0. So that's what it says. So let's see what the text says. It says that this function block is used as SR memory with the property set dominant. Output Q1 becomes 1 when S input becomes 1. The state remains even if S goes back to 0. Output Q1 changes to 0 when the R input becomes 1. If the input S1 and R1 are both 1 simultaneously, the dominating input S1 will set the output Q to 1. When the function block is called for the first time, the initial state of Q is 0. Okay, so this is a truth table which summarizes that if S and R are off at the same time, then we have the old state for the output. If S is off and R is on, then the output is off. And if S is on and R is off, then the output is on. And if both of them are on at the same time, then S dominates. So the one here tells you that S is the dominant. Now let's see what the RS flip-flop says. It is the same function block or similar function block, but what changes now is that this one is a RS flip-flop. This one is a reset dominant. I can clearly see that the one this time around is attached to the reset input, not the set input like the case of set reset flip-flop. Okay, so let's see what it says. It says that this function block is used as RS memory with the property reset dominant. Output Q1 becomes 1 when S input becomes 1. The state remains even if S1 goes back to 0. Output Q1 changes back to 0 when the input R1 becomes 1. If the input S and R are both 1 simultaneously, then the dominating input R1 will reset the output to 0. When the function block is called for the first time, the initial state of Q is 0. So this is the function table or the operation table which summarizes this. It also has the enable and the error notification pin. So you can, like I said earlier, you can use it to control when you want this block to be executed. When it is enabled, the block executes. When it is not enabled, the block does not execute. Okay, but by default, it is always enabled if you don't attach a control variable to it. Now let's see the operation table. The operation table says that if both of them are off at the same time, then it has its old state, and if S is off and R is on, then the output is off. If S is on and the R is off, the output is on. And if both of them are on at the same time, then the R input dominates and set the output to 0. Okay, hope that makes sense. So let's look at some exercises. Exercise says that design a PLC ladder logic program that will implement motor start, stop, and emergency stop operations using a flip-flop. So you can take some time and pause this video and try to realize this logic. This is a wiring diagram. The start, stop, and the emergency have been wired respectively to input 0, input 1, and input 2, and the output has been wired at output 0. And this is the function table. And from the function table, you see that when all of them are off at the same time, the output takes its old state. And if the start is off and stop on, and irrespective of the state of the emergency, the output is off. And if the start is off and we don't care about the state of the stop input and the emergency is on, the emergency will stop the motor. And if the start is on, irrespective of the state of both emergency and stop, then the motor will be on. So this clearly tells us that this is a set dominant flip-flop, because irrespective of the states of the stop and the emergency operation, the output is on. So the output follows the start operation, and the output takes its old state when all of them are in the off position. Okay, so this will be the logic that will implement this functionality. All right, so let's go now to our software to test the logic. Okay, I've already pre-created a project and I've already declared some variables. The variables that we are going to be using. We'll be using the emergency stop, which I've attached to this address, the motor, which I've given it this address, the start and the stop. So these are the variables that we have created. Okay, we have already explained how we can create this variable table in our previous tutorials, and I've also already created a sample project which I've called example flip-flop, a ladder logic project. So you can see here it tells you that it is a ladder logic project, and now we are going to build that logic inside this environment. So to do that, we are going to go to our library and search for the SR flip-flop. So I will click on it, and I'll just rearrange this window. Okay, so you can type it here, SR. So it comes up, or you can search for it, and I'll drag it to my environment, and I'll close it. Then I will drop 3 normally open contacts. I'll wire them up as such. I'll give this a start, address, stop address, of the emergency stop, and here I will attach my motor. Okay, so I've constructed a project. We have to analyze it. Delete. I will now connect my PLC, and I will transfer my project. So I'll just highlight everything, and then I'll create animation table. So I'll just rearrange the window and close this one. Okay, so let's start the testing. So now all of them are 0, 0. The default value for cure is 0. So if I set it to the force mode and I start the operation, the motor is set to 1. And the motor, if I release the start button, the motor stays to 1, to the 1 state. And if I set the stop to 1, the output resets. If I bring it back to 0, the output stays at its reset state. I set it again to 1 by the start operation, and I bring it back to 0. I can also reset it with the emergency stop, like that. Okay, and if all of them are 1, 1, 1, for example, emergency 1, stop 1, and start 1. Okay, there set dominates irrespective of these states. Okay, and if all of them goes back to 0, 0 and 0, then the motor stays at its old state. Okay, hope that makes sense. All right, so let's go back to our presentation. Okay, so now let's review what we have learned. So congratulations, you have now understood that in the set reset flip-flop, the output will be true if both S and R inputs are high, and in the reset set flip-flop, the output will be false if both S and R inputs are high. So this is a reset dominant, and this is a set dominant flip-flop. Okay, in the next section, we are going to look at edge detection logic instructions. And please, if you find this video helpful, give it a thumbs up, share it, and subscribe. And if you think that there is anything that needs improvement in this video, please share it with me in the comment section. Thank you very much, and see you in the next video.